why the number of attendees is very minimal?
Sir, audience, max class, whatever, just now, sir. They'll be joining you, sir.
Little louder, Arun Balaji.
Sir, Friday's max class just ended a few minutes ago, so they'll be joining you, sir.
Oh. Anyway, we will start. Already we gone 7 minutes. Anyway, we will start. My slides are visible.
Yes, sir. Yes.
Yes. Yes, very good morning. And this is what we have seen in the last class. We refresh the content which is disseminated during last class. And we were introduced sensors, and we were disseminated the difference between the sensors and transducers. And basically, a sensor is a measuring device, and whether we can measure the displacement, temperature, pressure, and based on the conversion of voltage, current, and capacitance, we can able to measure these the displacement, temperature, and pressure, and etc. And even I have disseminated the minor difference between the sensors and transducers. And usually the displacement sensors used for the measuring the movements of an object, and the position sensor are employed to determine the position of an object in relation to some other reference point. And the proximity sensors are a type of position sensors which is able to detect the presence of nearby object without any physical contact. Even without the physical contact also, we can identify whether the component is available or whether it is gone. And so very few examples of the displacement sensors: potentiometer, LVDT, strain gauge, capacitive sensors, encoders, Hall effect sensors, and inductive sensors. Among these sensors, probably today we will see the three different classifications of this typical example. One is LVDT, inductive sensors, and capacitive sensors. If time permits, we will see even other sensors too. And this was the potentiometer. Potentiometer works on the principle of change of resistance of the wire with its lengths. Based on its length, the potentiometer works. Usually, in order to measure the linear and angular measurement, the potentiometers are used, and it works on the principle of conversion of mechanical displacement to an electrical signals. The sensors as a resistive element, and a sliding contact based on the wiper movement. It gives it returns the values, and the slider moves along this conductive body, acting a movable electrical contact. And this was the photograph of potentiometer, and some other slides which is related to potentiometer. Even we have one video in the last class which details about the working principle of potentiometer. And this is what the application of potentiometer. The sound engineers has to depend some system in order to have very fine sounds. For that, usually they may prefer the potentiometer. The potentiometers is used. The throttle position sensors is used to measure the position of the throttle butterfly valve, how is oriented, so that ECU known how much air is flowing into the engine. And it is used to audio control system to increase the amplitude of the sound, and other applications, and advantage and disadvantage. And this is what we have seen in the last class. And concerning the today's presentation, and today we'll see we will start from LVDT, inductive, and capacitive proximity sensors. And why we are concerned about sensors? What was your vision? Why we are concerned about sensors? And for today's class, I request some people to join with us till the end. And I think Only 65 people alone joined. The second 10 people, I request Anantha Krishnan, Anil Kumar, number 11, Janyan Singh, Anurag Dash, Anurag Janjir, Arvind Roshan, Ashish Kumar. I think these people I have requested in the past class itself to join. So I'm moving to the third 10 people, that is Balamurugan, Rohita, Bhumika, Bhavya, Kalyan, Chitash, Deepak, Durugupta, Divyadashni, Chandravashni. You please unmute your mic and please join with us.
Yes, sir.
Yes, sir. Yes. Till the end, you please join with us. Yes. Balamurugan. What was the last class content, Balamurugan? Balamurugan not yet joined. Rohita. Sai Rohita. She is also not joined. Bhumika. For whom we are talking, that was a very big question mark. See how this is what the response from your side. It is very poor and it is very unfortunate. Bhavya. Bhavya. Kalyan. Chitash.
Sir, I think sensors and transducers.
Just a minute. Yes, Chitash. Kalyan. Little louder, Chitash.
Sir, last class we discussed about sensors and transducers.
No, I am asking about today last session.
On-stage speeches.
We had Max.
Yes. What all the topics covered in the last session, Chitash?
Sir, partial correlation.
Okay.
Sir,
Partial. Yes.
which class you are asking?
Mathematics. Yes. Past session.
Yes, sir. Correlation.
Okay. Correlation. Okay. Okay. What is your understanding about the correlation? Why we need correlation? Dhruv Gupta, Divyesh Dashni, Chandravashni. Chandravashni, you unmute your mic. Deepak Surya. See, this is what in order to talk with the system, in order to talk with a bloody black box, there is no, it is not essential to have a talk with this computer and all. Everything knows with inbuilt, they have the things which we are disseminating. We are talking with the people, but the people won't listen and people won't responding mean what is the need for disseminating these contents? When we have CT at that time, the number of views in YouTube elevated more. Okay, anyway, we'll discuss about the LVDT. As I said in the last itself, the LVDT is a linear variable differential transformer or transducer, and which is used to measure the linear displacement with an input range about 2 to 400 mm. It has a linear error percentage of 0.25, and in LVDT we have three different coils. One is primary coil. At the center we have the primary coil. On the other two sides, on both left and right sides, we have secondary coil, and which is equally spaced, and the number of turns is uniform in all the three. And when we have some core, when we are moving this core at when we are keeping the core at its center, what happens? The flux produced in the primary coil. Mm, uh, Flux produced on both the sides on the secondary coil will be zero. Therefore when we are keeping the core at the center, then it is usually called as a null portion, because the observance or the EMF produced in the secondary coils are zero. Therefore that portion is usually said to be a null portion. But when we are having the core at its right side, let this may be S1, and we'll call it as this may be in S2. That is coil 1, let it be C1, and coil 2 let it be C2. And here when we are keeping this core at nearer to the right side, the EMF produced in coil 2 is greater than the EMF produced in coil 1. Therefore the difference in the EMF when we are subtracting with the EMF produced in coil 1 with coil 2, we will get a negative value. When we are keeping the core at its left, what happens? The EMF produced in coil 1 is greater when compared to coil 2. At that time, we'll get the net results of the EMF produced or flux linking will be greater. That is positive. The LVDT uses the magnetic and polarity of the net EMF induced to measure the displacement of its core from the null portion. And it has three coils, as I said, three coils, which is usually placed placed centrally. And these are the two cases which I have designated: and alternating voltage input to the primary coil, and alternating electromagnetic force are generated in the secondary coil. When the magnetic core is centrally placed with its half portion in each of the secondary coil regions, then the resultant voltage is zero. That was said, that was usually called as a null portion. And when we are keeping the core on either sides, when we are keeping the core at coil 2, the net EMF is negative. When we are keeping the core, then we should have some equation, that is the net EMF ET, net EMF, let it be ET, is equal to E1 minus U2, EC1 minus EC2. EC1, where EC1 is EMF produced in coil 1, and that was in left, and C2, let it be the coil 2, let the EMF produced during coil 2, that is on the right side, is EC2. Therefore ENT is equal to EC1 minus EC2. And when we are keeping the coil at right side, the net EMF is negative. When we are keeping the coil at left side, the net EMF is positive. That is what detailed in case 2. And if the magnetic core is further displayed, then the value of the resultant voltage is increased in proportion with the displacement. Therefore, LVDT uses both magnitude and polarity, and various applications of LVDT are in factory automation and the process control, high temperature applications, material testing, and industrial application, hydraulic actuators, and the application which is related to larger misalignment, and the pressure chambers and vessels, the rolling mill, and the casting mold camping, and servo mechanisms, weight sensitive applications. And the few advantages of LVDT are it has high measurement range, which is ranging from 1.25 mm to 250, and with this range differs from author to author. When we are in the first slide, we have 2 to 400 mm. See, some author revealing the ranges varies from 2 to 400 mm. Some author revealing the ranges from. See, this is what the position. This is what the position of two different cases which I have told earlier. This is the center position. This is on one side. This is on the other side. We'll get the output difference, and the liquid. In order to identify the position of the liquids, the LVDT are used. It is used to detect the diaphragm deflection, the help of which the pressure can be determined. And some authors reveals it ranges from 0.5 to 40 mm. Therefore, you please make a note of these different informations. It has low power consumption, which is less than about 1 watt. It is a frictionless device, and it offers high resolution, which is greater than 10 mm, and it is small in size, weight, and the solid and robust in construction. The tolerant shock and vibrations are it has excellent repeatability. It has a very low output impedance, and even it has a few disadvantage, and it is limited to dynamic response, and the vibration due to displacements can affect the performance of the LVDT, and even which is affected by the increase of temperature. And when we are concerning about DC output, the demodulator is required, and the larger displacement is needed for small, even for a smaller output. The larger displacements are essential for, and that was a few drawbacks of the LVDT. And we'll talk about the capacitive sensors. And the major two sensors are used in industry are one is inductive sensors, the other one is capacitive sensors. Usually the non-magnetic materials like glass, plastics, erasers, and dust tape, masking tape, pencils, bottles, even are the human hands are identified through inductive sensors. But in the case of capacitive sensors, it won't identify those things which I have told earlier. And in usually the inductive sensors are used in elevators, and the capacitive sensors are usually used to identify the liquids and dielectric materials. And yes, we'll discuss more about the capacitive sensors, and we'll ask someone to discuss the current affairs, and we'll come back to the capacitive sensors. Yes, go ahead with the current affairs. Any information related to the International Men's Day or any other issues?
Sir,
Edappadi, uh, Sir Edappadi announced that he will give 6 per year freely.
Yes, in the Tamil Nadu, very soon we have election, that with the legislative, and CM promises 6 free gas cylinders to each family. That was the manifesto, and that was the assurance given by our present CM. Even the homemakers will get 1,500 per month. That was in continuation with the DMK leader. He was Yes, in the yesterday's meeting, he was disseminated, assured to make rupees 1,000 for women, that is homemakers, and that was in 500 increased by the present CM. Yes. Some other content.
But international crude oil prices suddenly surged because there was an attack in the oil refinery of Aramco Industries.
Mm.
It was done by some their enemies, sir, who were deemed as terrorists recently by the US government.
That was that was reduced or the price raised.
Surged, rised, it suddenly rised.
The attack was
Surged because
increased the
Aramco
price.
Industries
I think there is a
an
problem
oil
with your
refinery and
echoing your.
sir,
Yes, yes. Go ahead. Go ahead.
Aramco Industries, they had a oil refinery in which their enemies, sir, Saudi Arabia's enemies, they did drone attacks and launched missiles on them.
Oh, oh.
So all of a sudden the prices increased and is the highest after May 2019.
Yes, already we have 93 rupees in Tamil Nadu. We have 93 rupees per liter. After this issue, they will definitely they will increase the price. Even there is a huge drop in the barrel price here. In India, they were increased day by day, and at this time, what they will point it out based on this issue. Again, we are rising. Okay. Any other information? Anand Modi. Anand Modi, I didn't hear your words in the industrial robotics class, Anand Modi. Anand Modi, Achit Naik, Ashwat Ram.
Yes, sir. Good morning, sir.
Very good morning, Anand Modi. Your belongs to uh, which state, Anand Modi?
Sir, Rajasthan.
Rajasthan. Okay, what was the status of COVID-19?
Sir, they're saying that there might be a lockdown if the
Ah,
cases rise the way
okay,
they are right now.
okay, okay. Okay. Any other? Any other? The number of the COVID persons increased in 5 different states, and Tamil Nadu is in the fifth position. And I think we'll come back to the capacitive sensors. This is what the content. The capacitive sensors are usually used to identify the liquids and the dielectric materials, and it is a non-contact type sensors, primarily used to measure the linear displacement from few millimeter to hundreds of millimeters, and it comprises three plates with the upper pair forming one capacitor. And see here we have three different plates. The upper pair having the one pair, making one pair. The lower pair making the other. Lower two plates are making other pair, and this is known as the push pull displacement sensors. And this is what the initial position in this movement at plate 2 makes the difference in sensing, which is connected to an element. And if we use two plates, the relation between change of capacitance and displacement is non-linear, and we have some equations. I'll little later we'll make detailed note about these equations and all. And the capacitive sensors, which is the electrical field polarize the external body. The polarized charge again the potential energy from the plates. We have see the capacitor usually will identify the whether we have liquids or we have the dielectric materials, or without dielectric material the objects approaching, that can be identified through the capacitive proximity sensors. And see, we have oscillator and sensors, and the magnetic field which is the metal sensing region, and DC output, and the linear displacement are in three different forms. The one of the plate is moved by the displacement, so that the plate separation changes, and the area of overlap changes due to the displacement, and dielectric fluid changes between two plates. And see here, when the object approaching the region, the capacitor region, here the what happens, the area of this region will change, and based on that it actuates. Here we have the actuation. We can able to see the actuation at this point, and based on that it will actuate, and it will separate whether if it doesn't have any liquid or any milk or any dielectric things, and that can be lifted down. This is one particular sequence. See here, and liquid. Yes, when it has a dielectric constants which is greater than or equal to 1.2, and that can be measured by capacitive proximity sensors. And concerning the inductive proximity sensors, and this is what the picture related to the inductive proximity sensors. And the initial position of this inductive proximity sensors is lower when it approaches. This is usually applied in the elevators, and when the oscillator circuit or the setup of inductive proximity sensors is very near to the target, what happens, it may changes over this oscillator circuit, and it can, based on that it can sense. This is what happening in the inductive proximity sensors. And see, when it was approaching target, this is what happening. uh, when we have the normally closed actuator, it opens and it allows for further operation. That is what happening in the inductive proximity sensors. Yes, some applications of capacitive sensors. It is usually used for measuring the linear, even for angular displacement, and measuring not to measure the humidity in the gas. The capacitive transducers are used. Even it can be used to find the volume and the liquid level and the density, and so on. And it has some advantages, and it requires small power to operate, and the loading effect is less due to high input impedance. The sensitivity of capacitive transducers is high. The capacitive transducer is usual for a small system, and it has a very good frequency response. And similarly, on the other hand, we have the disadvantage. The output impedance is purely depends on the frequency used. The capacitance may get changed by dust particle and moisture, which produce error. The capacitive transducer are temperature sensitive, and it gives non-linear behavior. And the optical encoders will talk little later. This is what the content will we need to talk in the subsequent class. We will talk about optical encoders and the incremental encoders, absolute encoder, and the application of these encoders, and Hall effect sensors, and various application advantage and disadvantages of these Hall effect sensors. Now we'll talk about the inductive sensors. As I already said, the inductive sensors are generally used in elevators. It is a proximity switch, or basically used for detection of the metallic object. An alternating current is supplied to the coil, which generates a magnetic field. Based on the magnetic field, the objects are identified. When a metal object comes closer to the end of the coil, the inductance of coil will change. This is continuously monitored by a circuit, which triggers a switch when a present value of the inductance changes is observed, and based on that, the further operation carries. And the industrial automation containing of the products during production or transfer, during detection of the metal object, armed landmines, for in order to perform the security measures, we can use the inductive proximity sensors. And see here, we have the target. Based on the metallic object detection, what happens? There might be changes in the output signal. Yes. Here, when the high frequency metallic field will be there in the measuring device, when this measuring device approaching objects, that too with metallic object, what happens? It definitely will affect the magnetic field. The eddy current generates the energy loss due to the resistance of metal, which reducing the amplitude of oscillation. Based on that, we'll observe will identify the signals. And the machine tool, machine assembly line, the automotive industries are wide users of this inductive proximity sensors, and the detection of metal parts in harsh environment, and high speed moving parts are generally used by the inductive proximity sensors. And the advantages, the contactless detection is a very good advantage of this inductive proximity sensors. When we have contact, what happens due to that continuous contact, we need to do repair and servicing is essential. But in the case of inductive proximity sensors, it doesn't have any contact. Therefore, that is a very good advantage of inductive proximity sensors. And environment adaptability, that is resistance to common and conditions in the industrial area, such as dust and dirt. Even that conditions also it may work very smooth, capable and versatile in metal sensing. And the switching rate is very high, and there is no moving parts. And as I said, due to non-contact detection, it doesn't have any moving parts, ensuring a longer service life. And similarly, it has the disadvantage: the lake induction range, averaging a maximum range of 1060 mm. That may cause that might be the very big disadvantage, and can only detect metal objects. And that was the restriction. And the external condition, like extreme temperatures and cutting fluid or chemical effects on the performance of the sensors. Therefore, we need to be very conscious over these points. And this is what the other piezoelectric sensors. And what happens when we have dealing with this material like quartz? See here, quartz and lithium sulfate and ceramics. What happens? Have you aware about these materials? Anywhere you use these materials, either or quartz or ceramics? So, generally, ceramics are used in Yes, someone, do you want to share anything? Mahadev Agarwal, Gurishwar.
Yes, sir.
Yes, Gurishwar, do you want to share anything, Gurishwar?
No, sir.
No, you're from?
I'm from Trichy, sir.
You're from Trichy.
Yes,
Okay,
sir.
where you are staying?
Near Srirangam, sir.
Oh, good. Okay, Mahadev. Okay. See here, this is what happening in the capacitive proximity sensor. And when we have target, when the target is approaching the area of the circuit, what it tries to have the uniform area. Therefore, it actuates the switches. And this is what about the photoelectric proximity sensors. The photoelectric proximity sensors which have a very fine range of 1 mm to 25 meter or more. Even for a longer range, what we need to prefer, the photoelectric proximity sensors. And here see, we have the proximity sensors. When an object is approaching here, what happens, the emitter emits the signals, and that was received by a receiver. And this portion called dark operated portion, when some obstacles interrupting this signal, when what happens, the see here, this is called the light operated. When some targets approaching, interrupting the signal, it interrupts, and that portion is called light operated mode. And when see here, some ball is approaching the target, and what happens, immediately it activates the switches and it stops the movement of this slide. You see here, when we have the light operated mode, we have, when there is an we are working with some material. When material is in the base plate, what happens, it is in light operated mode. When this target moves, what happens, we got the signals and it again back dark operated mode. At that time the alarm will come. What alarm says, we doesn't have any material to work, like that it indicates. This is what about the photoelectric proximity sensors. And similarly, we have other sensors called piezoelectric sensors. The piezoelectric material, when stretched or compressed, it generate electrical charges with one phase of the manager will becoming positively charged, and the positive phase negatively charged. And as a result, a voltage is produced. And some the mathematical relation over piezoelectric sensors. I'll little will talk about these mathematical equations and all. And see here, we have four summing member, output voltage, and we have base. The crystal is positioned here, and this was the photograph of piezoelectric transducers. And this will continue during the next subsequent class. We will talk about this application of piezoelectric. I think we'll wind up with this application. As piezoelectric material, it cannot measure static values. These are primarily used for measuring surface roughness, and in accelerometer, and as a vibration pickups, they are used to Yes, just a minute. Yes. In order to find the fine roughness of the measuring devices, if you are willing to measure the roughness of the cylindrical component, or whether it may be the milled component, or it might be a drilled component, at that time what we need depend the piezoelectric transducers. And it is a very important measure concerning the manufacturing industry. Roughness, if we have very fine finish, then the quality of the component will be more. When the roughness value is more, it seems the quality of the component is very minimal. Therefore, it is a very fine feature, and for that we need to depend the piezoelectric transducers in order to measure the surface roughness of the component. Usually, the surface roughness might be the average deviation from the datum. That was the surface roughness. And the strain gauge to measure the force, stress, and vibrations. It is the piezoelectric transducers are used, and in automotive industries, and or usually used these piezoelectric transduction in detentions in engines that are used in ultrasonic imaging in medical applications too. And the few advantage and limitations of this piezoelectric transducers. These are active transducers, that is they do not require external power for working, and are therefore self-generating. And the high frequency response is a major advantage of this type of transducers. And concerning the limitation, the temperature and environment condition cannot affect the behavior of the transducers, and they can only measure changing pressure, and they are unless while measuring static parameters. And this is what about the advantage of piezoelectric transistor. What we have seen today, we have discussed four different sensors. One is LVDT, and the second one is capacitive proximity sensors. The third one is inductive proximity sensor. The fourth one is photoelectric proximity sensor. At the last, the fifth one, we have discussed about piezoelectric transducers, and we were discussed the advantages as well as we were disseminated the disadvantages. And do you have any doubts with these slides? Do you have any doubts?
No, sir.
No, sir.
Yes. Do you want to share anything?
Sir, I have a doubt, sir.
Yes. Go.
Sir, like sir, in PPT it was written, sir, inductive proximity sensor can detect only metal targets, sir.
Yes.
So for non-metal parts, non-metallic glass, plastic, which sensor we will be used, sir?
We are using inductive sensors. Inductive sensors can measure the non-metallic materials.
Yes, sir. That is my doubt, sir. In PPT, it was written, sir, it can detect only metal parts, inductive proximity sensor. PPT right now you share it, sir.
Oh, okay. In inductive sensors, it was written.
Inductive proximity sensor. It can detect only metal target.
Wait, I am checking.
Yeah, thank you, sir.
Sorry. The proximity, the capacitive sensors can be used. Capacitive sensors can be used to measure these type of glass, plastic erasers, and that is not possible
Yes.
by inductive sensors. That is not possible by inductive sensors.
And we can also use photoelectric sensor for the sensor, glass, plastic, or not, sir.
Yes. We can use. Yes, we can use.
Yeah, thank you, sir.
Yes. Any other doubt?
No, sir, no doubt, sir.
Okay. We'll meet tomorrow 12:30. Thank you.